All right, so for those who want to see where it comes from, we're going to start with just the regular ax squared plus bx plus c. All right, so I don't know if I've mentioned this, but before you can actually factorize or anything, you must remove the coefficient of a. So I'm going to divide that through the rest of the quadratic. So it's going to look like this, plus c over a. Now when I do that, I haven't removed a completely. There's brackets around it, and there's a on that side. Important also to remember is that when we're finding x-intercepts, this whole thing is equal to 0. So that's going to sit there. I won't always draw it, but we need to remember it's there. So the next step is I'm going to complete the square. So I'm going to halve this, which is, I remember it's only the middle coefficient, so it's b over a. So when I halve a fraction, I double the denominator. Then I'm going to square it, so it becomes b squared over 4a squared. So I'm going to have to add that in, b squared over 4a squared, and subtract it out, b squared over 4a squared. And that should really be just inside those brackets there. So the next line down is going to look like this. You notice that it's getting quite complicated. I'm going to switch from using rounded brackets here. I'm going to make them square because I need to use 2 sets of brackets now. So the whole thing that I've just done is going to look like this. bx over a plus b squared over 4a squared plus c over a minus b squared over 4a squared, close bracket. So then I can remember from completing the square that I am allowed to factorize the first 3 terms, and they factorize neatly like this. Squared plus c over a minus b squared over 4a squared, close bracket. Next line down, I'm going to try and simplify those final 2 terms. I'm going to leave the factorized brackets as is for now. Hopefully you're starting to see some connections between what the quadratic formula ends up looking like and some of the terms we have in here. So to simplify these 2 fractions into one fraction, I need to get a common denominator. The common denominator means multiplying c over a times 4a, because that's going to produce 4a squared. So plus 4ac over 4a squared minus b squared over 4a squared. I didn't need to do anything to the b squared fraction because it already had the same denominator as what I was aiming for. So now I can write those as one fraction, and it will look like this. I can write it as plus 4ac minus b squared all over 4a squared. All right. Now comes the time for us to actually get x by itself. And you remember, because the 0 is sitting there, we can just start rearranging things one step at a time. So the first thing I'm going to do is divide by a. That will get rid of the a out the front here. 0 divided by anything is just 0, so that changes nothing and neatly gets rid of the a for us. So now we're looking like this. B squared over 4a squared. And at this point I can say to myself, there's no a, so I can get rid of the square brackets, because the next step I'm going to do is to move this constant to the other side. So we're going to move it across to the left hand side, and we're looking like this. 4a squared, it's going to be all negative, equals x, that should be x plus b over 2a squared. Now you might remember that on the left hand side, if I have a negative here, when I square root to get rid of the square, this is going to produce a number that we're not allowed to do. However, with a bit of fancy maths, I can expand this negative through the expression and get rid of it. So expanding it through means multiplying everything in the expression by minus 1. So it will become b squared minus 4ac all over 4a squared equals whatever's on this right-hand side. All right, now I can square root both sides, and you're starting to see where the quadratic formula comes from. Oop, that's a 4a squared equals x plus b on 2a. Then the final step is to move the b on 2a across to the other side and end up with minus b over 2a plus or minus, because when I square root something here, there's a positive solution and a negative solution, plus or minus the square root of b squared minus 4ac all over 4a squared. Now this, you can see how it's getting towards the quadratic formula, but it's not quite there, is it? So you might remember that to create 4a squared, we just squared 2a, which indicates that this denominator inside the third can be reduced back to 2a. So it's going to look like this, plus or minus the square root of b squared minus 4ac over 2a equals x, because the square root of 4a squared is 2a. Then I notice the two denominators are the same. I can combine the fraction into 1. So it looks like this in the final step, all over 2a equals x. And that is where the quadratic formula comes from. It also shows you along the way some really neat information, being that this is the little formula we use to find the turning point, minus b over 2a, which is this part here. Because the reason that's the turning point is because if you think about this, this number, whatever this is worth, is the same in both solutions. So that indicates that this is the axis of symmetry. Somewhere along there is the turning point. And then to find the x-intercepts, I move a certain distance that way and that way. So there's one, and the same distance that way. So if you're stuck, minus b over 2a will always find you the axis of symmetry. Okay, so to recap, the quadratic formula comes from completing the square of just general form with no numbers. You don't need to know it, but if you're interested in finding that out, that's how I did it.